Point 2. I'm going to call this part 3. I'm going to call it symmetry because that's what it is. All right, so here's how I'm going to format this last part. You're going to need like at least this much. If you don't have this much left on your paper, I might go to the next page. So I'm going to draw 3 graphs, and they're just going to be sketches, and they don't have to be too giant, but I wouldn't make them smaller than the height of 3 lines in my notebook paper. They can certainly be bigger, but I wouldn't make them smaller than this. And what we're going to do is we're going to show 3 examples of symmetry. So a graph can be symmetrical to the x-axis. And I'm just going to bold out like some symmetrical points there. A graph can also be symmetrical to the y-axis. And we've all seen these before. These are parabolas. And just kind of bold out some points in your sketch that look symmetrical. And they're just sketches. They're just our notes, very informal. But do try to find some symmetrical points. Origin is going to be the last one that shows symmetry. So the best you can, try to draw that little swirl like that on the origin. And these have symmetrical points right here. Okay, so this, when you have a situation like this top row, this is symmetrical to the x-axis. Anything symmetrical to the x-axis will always have this situation. You're going to have a plane point, we're going to call it xy. But what's going to make it symmetrical is x will also give you an opposite output. Whoa! The x is just repeated. So anytime you have something that's symmetrical to the x-axis, it's never a function. Let's just write that down. It's great that we recognize the symmetry, but after that, we're pretty much done with it because we are a function-based classroom. All right. And then down here, we are going to have symmetry to the y-axis. And what we're going to do for this, we're still going to have a point, xy. However, the opposite input will give you the same output. So this time the y's are repeating, that's fine. The x's are opposite. So when that occurs, it is symmetrical to the y-axis, and it's also a function. And it is evenly distributed, so we're always going to call it an even function. So anytime, every time you have a graph, and I'm bolding this because this is kind of new words for us. Every time you have something symmetrical to the y-axis, it's also considered an even function. So that parabola gets 2 labels, symmetrical to the y-axis and even. All right, for this last one, so we can have things symmetrical to just this point, the origin, and that's what this represents. So this is symmetrical to the origin, and I always know stuff is symmetrical to the origin when you have an exact opposite output and input. So both of these are opposite. So the x values didn't repeat. So it is a function. And this one gets a name also. And it is called an odd function. And I wish I would have been consistent and wrote that in capital letters, but that's okay. And that is an odd function. So the word odd starts with a letter O. Origin starts with a letter O, so that's a good way to remember that. Okay, and then that is going to be, we're going to pick up on this tomorrow. If you have these notes, then you're set.